So first up, more importantly than everything, hello guys, thank you all for coming, and wow, there's actually quite a lot of you. So as Matt said, I'm Darcy. I like monkey hats, they're kind of awesome, or so do pretty much everywhere else. And the most important thing of my talk, I have a lot of slides, so I'm going to apologize because it's not a good thing to have going up against lunch. If I talk too fast, yell out and I'll try and slow down. And kind of the disclaimer to that is when I show code slides and there's a lot of code, don't even bother trying to read it because I'll move on to the next slide which will actually focus on it. So today I'm talking about hacking Sidekiq for fun. So making Sidekiq do evil things you really shouldn't do, or not even necessarily shouldn't do, but it doesn't do out of the box. And so it's actually applicable to people who work for someone and their work sent them, the and profit bit. So how you can actually use Sidekiq with, say, Amazon, for instance, and save quite a bit of money doing background jobs. So the most important part before I get going on how to do that is kind of what is Sidekiq and what's the history of background jobs. So background processing as a concept isn't new. Background processing has been around since before Rails, of course, and like back into early computer science stuff in 70s and that sort of thing. And if you come from an enterprise background, it's kind of a given. And as the Ruby way is, we kind of reinvented it over the years. If you're not kind of used to thinking that thing, it's primarily about complex logic with many side effects. Things that, say, for instance, are rather slow, can take a while to run, or you're talking to a bunch of external APIs, things that you don't necessarily want in that request-response lifecycle of HTTP. You want to be able to run this code, and it's not going to change what the user gets back, but it needs to happen somehow. So using the previous example, you have some API that serves up data from an external source, and you need to update that all the time. And so the user doesn't necessarily matter if it's fresh when they get it, but you want to make sure it happens. So pushing that out to run it in the background separate from your web request is a really good way of solving that. So like I said, Ruby has a history of this. I'm going to skip through a bit, but go through the kind of like 4 main options that we've had historically as we've learned more and evolved and our tool set has evolved. So the first one is a project called Background RB. Background RB was kind of like this server and client integrated with Rails. There was a plugin. You know it's really old when, and this will be a sign of who he has been doing Rails for a while, the README is on RubyForge still, and the README tells you how to install it using Piston. Next up came Delayed Job, and Delayed Job's big leap was, well, it's probably a bad idea to be using a daemon with custom persistence, because that's going to fail. So Delayed Job decided that instead of storing all these things in a custom format on disk and a custom daemon, let's just use your database, because every app already has a database, and then pull it out of there and just use like rake tasks or a simple script to invoke it. Next up, and the big kind of leap in popularity was Rescue, coming out of early days of GitHub. And Rescue's big logical leap in kind of changing things was, instead of using a database or a custom daemon to persist things, Rescue used Redis. So a lot of apps are increasingly kind of adopting Redis as an extra data store, kind of this complementary part to your normal relational database. And Rescue leveraged that and used all the kind of built-in operations to implement this really nice, really fast, and more importantly, really easy to run queue. And on top of that, it added a bunch of tooling that made life easier working with jobs. And that brings us to today's topic, which is Sidekiq. So Sidekiq is the project of a Rubyist called Mike Perm. He works for a startup called The Climb. And Sidekiq has a bunch of new advantages, but the single biggest out of anything Sidekiq did compared to previous options was threading. Threading in Ruby for a long time has had this like really, really bad rep, mainly because of the global VM lock in MRI. And Sidekiq was kind of the first major, well-adopted background processing queue that instead of, say, having one process for every job you run, could run multiple jobs in multiple threads. And it did this really well in terms of maintainable code, not dealing with all the painful parts, using act-based concurrency. So if you're at the concurrency talk yesterday, you may have heard about that, and more importantly, Celluloid. So Sidekiq is built on top of Celluloid and acts as a really good example of how you can actually build production software using Celluloid in just different projects. And the key part of this is that even in MRI, even with the global VM lock, threading is still incredibly useful. You shouldn't discount it out of hand. Because networking heavy logic, which you're going to have a lot of, writing to your database, talking to APIs, all that sort of stuff, or even writing to the disk, MRI is smart enough to automatically like context switch there. You don't need to do all this hacking on top of that and dealing with it. Like you get that concurrency. So like Rescue, Sidekiq is built on Redis. So it uses Redis for job and metadata storage. So not only storing kind of like what we're doing, but also information about when it did it. And as we'll see in a bit, we can kind of extend that and use it for extra custom stuff. And as a big kind of bonus, it uses the exact same Redis layout out of the box as Rescue. So what I mean by that is you can use the rescue client to push jobs into Redis, or you can use Sidekiq to push jobs into Redis, and then you can use either of them to pull them out. If you're going for an application that already has a bunch of rescue workers, you can just drop Sidekiq in and run alongside it pretty easily. Or you can slowly migrate, and the other part of that is you can use it in different languages. You can push to jobs, push to Redis with Go or JavaScript and pull them out. And from an actual practicality point of view, it's batteries included. So there's a lot of really useful things like delay job and rescue meant you had to add gems and find the best one and the one that was updated that Sidekiq just does out of the box. Things like built-in exception reporting. You're dealing with basically a black box running code. You want to know when things fail. Out of the box with things like rescue and delay job and background RB. Typically, like if it fails, you don't know. Or the people, like you've got to spend some time working out what the best gem to add compatibility is and all that sort of stuff. Sidekiq kind of, it's a simple thing, but it just, whenever it encounters an exception, it pushes there automatically if you've got them in your project. It also ships with, by developer standards, a very good looking dashboard that gives you insight, like how many jobs are you running, how many per day, how long has your Red's been running, how much memory, gives you control over queues and all this sort of stuff. An interface basically to get some insight into what your queue's doing. So again, it's removing that black box aspect. A small thing, but incredibly useful again, is when your jobs fail, they will automatically retry. And it's smart about it. It won't just go, okay, retry straight away. It'll do like binary exponential backoff typically, or things along those lines. So it'll take its time, and it's smart. You avoid a lot of common issues with rolling it yourself. And a big one that I don't think any of the other options do out of the box is also scheduled jobs. So instead of just saying, I have some logic, do it whenever you can, scheduled jobs are about queuing them. So saying in 10 minutes, or more accurately, like say a week from now or a month from now, do this logic. Instead of having to say, write cron jobs that go, okay, who signed up a week ago, and send them an email asking why they haven't used the site. You can actually say for the user, like a week from now, tell me to do this. And that inverts how you think about solving those problems, which is a really useful thing. And of course, kind of a given on all of them is support for many queues. So a way to logically group things and how workers work across different contexts. It's built to be extensible, so things like retries and exception handling, all of these are actually built using middleware. If you're familiar with Rack, it's exactly the same concept. Before you actually invoke your code and when it's started, there's this chain of things that can kind of influence how stuff works. And more importantly, we'll talk about that a bit shortly, because that's what we're going to be hacking with today. And the other thing that makes Sidekiq different to a lot of projects is there's actually this kind of accompanying project called Sidekiq Pro. So Sidekiq itself is open source and licensed under a really good license. Sidekiq Pro is Mike's kind of paid for option. It's all these kind of features that are useful to have, especially when you're building big applications, but not everyone's going to use them. And in fact, the majority of people using Sidekiq aren't going to need Sidekiq Pro. But the features they offer when you come to them, you pay, I think it's $750. So features like batching, notifications, and reliable workers, and it gives them. And the two key ones there are batching and reliable workers. Batching lets you break down, say, I have 100 users and I want to do a job for each person, and reporting as a whole. Did all the users work or did just one? And reliable workings, like my server, like we have a lightning strike and the power goes out, automatically telling it, like detecting when it failed there. And probably the other part, because of the threading and its design, scales from a small number of jobs to many, especially if you're doing HTTP stuff. So for context, this is from our web interface in an app pre-production that I was working on. Without any users in the app, we were easily doing 500,000 jobs a day. Sidekiq never broke sweat. Redis never broke sweat. When we actually launched, we actually pretty quickly jumped up to, I think, the end of the first day, something along the lines of 4 or 5 million jobs in Sidekiq. And Sidekiq and Redis in that entire process had 0 issues. So how does Sidekiq work? So in order to hack it, you need to know how under the hood it works. And we're going to go reasonably deep here. The first thing to start with is a worker. A worker is your class that encapsulates doing some logic. It's a class with a perform method that takes some arguments. The magic comes when you include the Sidekiq worker module, which adds some wrappers around kind of talking to Sidekiq. And there's an optional Sidekiq options call. You don't have to do that. It will default to your queue. But you can pass a custom queue name, or for instance, you can like pass options to retries to turn that off. And your actual logic for a worker, all it does is it takes a list of arguments like any other Ruby method, and you invoke that. And the only difference is between you saying, I want to do this and it actually happening, there's this layer that pushes it off into the background. And as a bonus of that design, testing is really simple. You just instantiate that class in a test and you can test the perform method. Like it may be this magical layer in between, but there's a lot of work around making it easier and making that layer less magic and more just well thought out abstractions. So if you actually want to invoke that worker in the background, you use a method called perform async, you pass in your arguments, in this case my name, and it returns this magical hexadecimal string. All that is a unique identifier. You can use it later on and you can get it in middleware and you use it to work out what the that individual job was. Under the hood, and this is where it starts getting interesting, what that call does is this. It talks to the Sidekiq client class and it pushes a hash with two things. A class, which you'll see is an actual reference to the class, not a string, and arguments. So it's important to note here, we're still in Ruby land. So you can pass like active record object instances and things in args, but you're going to want to realize that when it's pushing to Redis, Redis isn't Ruby. You want to store things and you want to stick to things like instead of queuing a user object, queue a user object ID. Next, once that's actually called, that does a bit more magic under the hood. It converts it to a JSON job object. So you'll see again, our class now is actually a name of the class in Ruby. Our arguments are as they were, and a bunch of extra stuff. The queue you may recognize from our options, the JID, which is a job ID, the unique identifier, and some extra metadata like are retries enabled. And if it's failed and it's requeued, there'll be the number of times it's retried and all this other stuff. And the important thing to note here is our job is just a JSON hash. There's no limits on what we can add here as long as we can represent it in JSON. Next, once that's actually kind of converted to JSON, Sidekiq does this. And this is the same as rescue. If you're not familiar with Redis, the first line says we have this value called queues. Into the queues value, it's a set. So add the onboarding list if it's not already there. And all queues is a list of every queue Sidekiq knows about. And then finally, take that JSON encoded blob we just talked about and push it into the thing keyed by queue onboarding. If it's a scheduled job, much the same. The only difference is at the Sidekiq client push stage, we add an @ which is a float version of the Unix timestamp. And then we take advantage of a thing called sorted sets in Redis. And sorted sets are basically a set of individual things or a list. So we have the job data, but then each one has an associated value. In our case, that associated value is a timestamp. And then every minute or so, usually faster Sidekiq goes, is there anything now where that value is closer, is in the past? Really simple. It's hard to explain if you haven't done Redis, but it's kind of like one of those beautiful, elegant solutions. And more importantly, like we don't reference the queue in this one where we did previously. Remember, like our JSON has all this extra metadata. So when you're redoing that, you just pull that out of the JSON. How do we run jobs? We have Sidekiq Manager. So when you actually start the Sidekiq daemon, the first thing it calls into is this class. It's basically like an orchestrator. So it knows to talk to all the little bits and it knows to say, okay, every so often we should check for new jobs and then we should invoke them. Not going to go into too much details because again, you really honestly don't need to know that much. Suffice to say, this is where Celluloid comes in and it's a really good example. If something raises an exception, the way Celluloid is kind of linked with Sidekiq is it's very robust. It'll handle exceptions correctly and restart classes and all this other logic. The things that if you're rolling it yourself are incredibly finicky and easily to break. Next, and this comes into where we're hacking things, is a thing called Sidekiq Fetch, or more accurately, it's strategy. The strategy is the thing, this here being the main one you use in Sidekiq, that just pulls out work. It says, okay, I want a new job. How do I get a new job? In this case, it uses a Redis command called blocking write pop with a list of queues, returns the work. Like you don't have to understand how that works yet. Suffice to say, give it a list of queues, it gives you back a job. Pretty simple, pretty easy abstraction. But the important to note is it actually takes advantage, and it's very closely tied to Redis in this regard, of blocking write pop. The way you give commands to that influence things. Do you want to say have strict priority? If I have jobs in the user queue, do I always process them faster or before I process any jobs in an emails queue, for instance? Or do you use a sampling thing, like 80% of the time I'll favor user jobs? That's like, it's a very subtle thing, but it influences a lot of how your queue works and practical things like preventing queue starvation. Under this unit of work, you may have noticed there it returns, it's just a class that has the information about your job. So before it actually executes it, has the name of the queue, how we can re-queue it in the case of failure, and this little acknowledge method. So nothing actually happens in the default one, which is a good sign of extensibility, but you can do it for things like, okay, well now I can update the metadata and record this job was finished, or like you can send out an email saying it finished. The job is fetched, run through middleware and invoked. There's a bit more about that, but that's the core. And that's important to know now because we're going to take advantage of all of that structure, all tied together, to solve some really common problems in Sidekiq. So first up is unique jobs. And unique jobs is something we can implement only using middleware in Sidekiq. So without actually changing the internals of how Sidekiq works or anything like that, we can drop in this code that goes between where the manager retrieves the job and between when it actually invokes it, and we can make sure that jobs are unique. So this is an example of middleware in Sidekiq. That's the entire class. All it does is logs out information. More accurately, the bit you only care about is this. And effectively, you have a call method, you pass in the arguments with the worker class, the details and the queue name, and you yield if you want to do something. Any logic around that is up to you, and how you deal with that is up to you, but it's very similar to rack and other things, and it's nice, it stacks well. So in this case, we want to queue a job, but only if it's not currently queued. So consider the situation, using the API example before, we're loading external data from an API, and it may cost us $1 every time we access that data. So if we've never done it before, we probably want to do that like straight away. But if we've already got a job sitting there waiting to do it, we don't want to be adding 10 more that may do the same thing and cost us a lot of money. So specifically, we're going to be looking at a gem called Sidekiq middleware that solves this. And the first problem we have then is, how do we store job uniqueness? So how do we ensure that between every time we run this bit of code, the job is going to be unique? So I showed you server middleware, but we're also going to use client middleware. So you can do it between pushing the job to Sidekiq and between pulling it out of, pushing the job to Redis and pulling it out of Redis. So yeah, the pushing and pulling jobs part. This is the bulk of the code. Again, the only bit you care about is this. And more importantly, the algorithm's pretty basic. You generate a key from the job structure. So the top line there, given that hash of details, we get rid of anything that's unique. Like we remove the job ID because we don't care about that. And then we check if that job ID and key has been locked. So has Redis got con.get unique key? And then if it hasn't been locked, we set it. And then we push the job if it hasn't been locked. There's a little bit of Redis magic in there, like watch and all that sort of stuff. You don't have to care about that at the moment. Suffice to say, it's around making sure that it is atomic and it doesn't like break when 10 people are doing the exact same thing at the exact same millisecond. So given to generate that key, we hash the JSON of the job and just check the existence of the hash in Redis. Like that's pretty basic, pretty simple. In fact, you can do all of this on client side essentially. And yeah, it's kind of awesome that you can do that in middleware. Next up is the client side. And again, a fair chunk of code. All that matters is when you run your job, once we finish, we want to clear that lock. So you can actually turn that off and you say, I want to be guaranteed that all the time this job has only ever run once. But the default case is once the job has run once, okay, let's clear up the lock and let someone else do this. And this is essentially, you're in many ways implementing not necessarily a mutex, but a guard condition that's across processes, not just across like a single process with threads. So the next trick we're going to cover is adjusting running instances, which really, really transitions Sidekiq into more powerful territory because it's not something that you do out of the box. And as far as I've seen, none of the other options for queues actually even come remotely covering this. And it's about a core number of questions. First, how can we prioritize and schedule work? So you may be doing hundreds of thousands of jobs, or you may be only doing 10. But one of the things you want to do with background jobs, because they are running in the background, you want a way to control when they're running, if they're run before other things. We want to control the number of workers dedicated to tasks, potentially. So only ever let like 10 different threads attempt to send user emails because we don't want to hit our external email provider too many times, or different things along those lines. We want to be able to temporarily pause a queue. For us, we had some buggy code that every time the job ran, despite testing, it would corrupt a bit of data. That was bad. But the turnaround time of like fixing the code and pushing it out, or like manually editing the code on the server, you don't want to have to deal with that when that situation happens. So being able to hit a button and then instantly no other new jobs of that type are processed is incredibly important. And honestly, it's one of those things that I think should be in Sidekiq Core. And from the bit I talked before about scheduling, actually saying this queue, no matter what, is always going to happen before jobs in this other queue. So here you can say, I have 10 jobs in a pipeline that I want to run, but the first 3 are always more important before the other 7. And the whole goal of all of this is one simple thing, which is you want to dynamically reorganize workers without process changes, which sounds like a mouthful, but essentially all it means is we have a bunch of servers. We don't want to have to stop and start things to change them. We don't want to have to deploy new code and all that sort of stuff. Like you're dealing with a complex system that's processing a lot of jobs. You want to be able to use metadata, in this case using Redis, and control how that works and control the semantics of our running system. So this is The specific example we're using is a thing called Sidekiq limit fetch, the name being an ode to the fact that it uses the fetch part of Sidekiq heavily. And so the first thing, we talked about Redis before and arbitrary data, and I kind of tried to stress how important that was. Limit fetch stores a lot of extra metadata. It stores all of those priority data, all of the pause states, everything that we use to control the system is stored in Redis, which is beautiful because you don't actually have to do much more. The gem just adds it and you don't have to like migrate a database table or anything like that. And it actually acts on those settings stored in Redis to control the system state. And the way it does this, because there's a very subtle condition here, is kind of awesome, and it's what makes Sidekiq limit fetch a good example. So this giant chunky bit of code here, you'll notice it's not highlighted and doesn't kind of look like Ruby. My first inclination when I saw this, and I spent probably about half an hour reverse engineering it originally, was, yeah, that kind of makes me really sad. And essentially what it is, to explain it, because I'm not going to make you read that code, I'm not that horrible, is it's a smart locking algorithm for jobs in Lua. And why it's in Lua is because it's running in your application's Redis server. So you're running dynamic code like you will with, say, SQL or even other languages running inside your database occasionally. You're running it inside of your Lua, inside of your Redis instance in this case, which, me being kind of evil, that was an instant sign of success. And why we do that is the subtle edge case I talked about. We use the Lua script to acquire a job instead of blocking write pop. Because if we're to do it in Ruby, there's all these race conditions. Like what happens if we check the metadata and then go to check the jobs? Actually running scripts inside of Lua has one condition. That script will be the only bit of code running on your Redis server at that time. It blocks every other operation. So the downside of that is your code has to be fast. And thankfully, Lua is a pretty fast language out of the box, but you have to be careful. Like, don't push all this stuff into Lua because you can do it in your database. But it solves this problem of we need things that are atomic that make sure no one else can conflict with us and get the exact same piece of work. The next stage, using that Lua, is we implement a custom fetch strategy. I'm not going to show you the code here because it's kind of boring. We also implement a custom unit of work class. So I talked about acknowledge before. Acknowledge in this case is the bit that controls the locking and pause queues and all that sort of stuff. And the final bit to tie it all together is we manage the metadata. So there's a bunch of things like, for instance, we add things to the web interface, which we talked about being extensible by middleware, but we can also add custom tabs and buttons and all that sort of stuff to the web interface. And it's one of those things where when you're actually using it, it's complicated and you're only going to need it every so often, but it transitions Sidekiq from just run some code in the background for me, which it's honestly the 90–80% use case. But the few times you need this, it's really powerful and it means you have a lot of control. The third, and honestly kind of rather evil, is, well, if we can replace how we get work, how about we change how we store data? Like, we're using Redis to store metadata and jobs and that, but necessarily we're not tied to that. So for anyone familiar with Amazon, there's this service called SQS, and SQS's description is quite literally a fast, reliable, scalable, fully managed message queuing service. My first reaction, of course, being excellent. Someone had already done the work for me when I looked at this, and the disclaimer, I believe, is there's no tests, but it's definitely production ready. I'm paraphrasing there a little bit, but yeah, the code was awesome. And the way it does this, like, so everything we've seen so far, the way we acquire work is pretty straightforward. We can do it without having to use Redis. But the downside to that, and why I don't advocate this, honestly, and it's worth knowing from an academic perspective, is that to actually implement this, it has to monkey patch the Sidekiq client push method to override the bit where we add it. So it uses SQS to actually store your jobs and to handle the queuing stuff, but it still uses Redis for metadata. So to make them work, it monkey patches a bunch of code, which honestly kind of feels a little bit dirty. But the upside of that is it's really clean to switch the fetch strategy. So actually pulling those jobs back is awesome. And like I said, avoid that because monkey patching is bad, and also the whole no test thing. And the final trick, and the one that kind of ties all of this together and makes it awesome, and from my perspective, this was a very practical thing, is using spot instances and auto scaling. So just as a really quick show of hands, who here has used AWS? Okay, and for those who have your hands up, who here has used or is aware of spot instances? Excellent. So spot instances average much, much cheaper. So spot instances is basically a marketplace for unused capacity. So Amazon has these huge numbers of virtual servers, but they're not always in use. So how do you make sure that you're getting your most value for money there? So they let people bid on them and like ask to pay a certain amount of price. The downside of this is they're transient and not guaranteed. Your server can be shut off halfway through running your work. But for certain sorts of problems, they're useful. So the normal price, for instance, for a C1 medium instance, which is, from my experimentation for most stuff I've done, that's the perfect size, it's like 2 cores and a decent amount of memory, is 14.5 US cents an hour. Compared to the spot price, the average across the last 3 months was 1.8 cents an hour. That's almost a 10-fold difference. For a company, like, you can save a lot of money. The downside to that is the peak price. So I said before, it's an auction, is $5 an hour. And people actually pay that. So there's this whole game theory level like that comes in about how you price and how you bid. So companies will bid, in this case, $2.50 or $5, and hope that when it hits that price amount, they're the only ones bidding for it, and that they'll only pay that for an hour. And over the long term, that will often work out cheaper. The downside being, I've seen in other regions and different instance sizes, the price for a spot instance stick at $10 a day when the actual normal price was about 25 cents an hour. So some company would have had a horrible AWS bill that month. And what this is perfect for, like given those conditions, it can go away at any instance, but it's really, really cheap. Anything involving big amounts of data or like spinning up servers and spinning them down all the time. And more importantly, like dealing with backed up queues. This is a perfect fit because you can just spin them up and you don't care if they go away. Or in plainer terms, I always want at least 5 worker servers. That's not an issue. But I can happily jump to 100 or 1,000 if need be. And the important next step there is you don't want to sit there launching 100 servers. Like, that's kind of a pain. So we can do it all without human intervention. And that's a really cool part. You have this system where we talked about before being able to control it at runtime, actually being able to control the servers at runtime and spin up more workers and shut them down and all that sort of stuff. So the way we do this is we start with Sidekiq, of course. It's running our jobs. It's the key part. Every so often, we talk to a service called CloudWatch. So CloudWatch is Amazon's service for recording metrics. This sort of approach works on any other kind of hosting provider where you can control servers via an API. The reason I'm referring to these services in particular is because they're Amazon ones and they're ones I've automated personally. So every few minutes or however granular you want it, you take those details from Sidekiq, like how many jobs are in our users queue, how many jobs are in our onboarding queue, and publish them to CloudWatch. Next, CloudWatch talks to auto-scaling, another service, and auto-scaling's entire job most of the time is given some number of value in CloudWatch, like how do I act on it? So in this case, like if we have 10,000 jobs sitting in our onboarding queue, people aren't going to be able to use our app. So we should spin up more servers. Or if there's none in there and we have servers sitting there doing nothing, we probably want to shut them down. With that information in mind, auto-scaling talks to EC2 and launches instances. And I mentioned spot instances before, but normal instances are charged per an hourly basis, so they can just as well be on-demand instances. But the key part here is, from your Sidekiq job queues, each stage of this is automatic and it reacts. As you get more jobs sitting there waiting, spin up more servers. As that kind of dies down, shut them down. And the final stage in this circle tiled altogether is we've passed in this data via Amazon user data. It's a way of saying sending a specific bit of metadata to an EC2 instance with queues or groups. We just read that queue group information and pass it to Sidekiq and start processing jobs. A lot of magic happens kind of in between there, but that's the core of the idea, and it's really, really powerful. So the core of that is the system responds to load and instigates measures to help solve it as it encounters that. And honestly, this only really matters when you're dealing with a lot of jobs, but the idea of having this system in place where, for instance, for us, you can have, like, wake up one morning, log in and realize, I think we ended up 100 extra servers running, is kind of cool. Except when things break and you've got to SSH into manually all of them and try and work it out. I've had so many times where I've sat there using things like, so this is a tool called CSSHX. Not fun, especially when you accidentally type shutdown. So in that kind of process, the one big thing missing from Sidekiq is a thing called queue groups. So queue groups aren't a concept in Sidekiq. So you have queues and you have workers and you can have multiple workers in a queue. But we wanted an extra level, and I know this is over abstracting, of stuff. So we want to say, okay, we'll use this in onboarding, like often we'll run them together. So we took advantage of another trick there. The Sidekiq YAML file, which is like this configuration that specifies what to process, is actually run through ERB before being passed. So we can use our environment variables there to kind of write some custom logic and use those environment variables to control like what queues we're running. The downside of that is I talked earlier about like how we want these things without restarting processes. You can't do that with that. So like we want to move to controllable queues per instance and group. So actually having something that says, well, you're running Sidekiq, you're running these queues and these are your priorities. I had a look, there's none really solid that I saw yet, so maybe it's an opportunity for custom extensions if any of you here kind of come out of this and go, I want to build something on Sidekiq. If not, I'm going to build it because it seems awesome. Not that I'll use it now. The kind of crux of all of this is I talked about them shutting down. So on spot instances in particular, you've got to understand that at any time they can just be shut off. You won't necessarily get the whole like minute of shutdown warning or anything like that. You act as someone walked over to your server and pulled the cable. So as a result of that, your jobs must first be idempotent. So you can run them many, many times. And if they've already been run, the result's the same. And you also must design them to fail gracefully. Things like using database transactions. You don't like write 10,000 different like parts of your 10,000 different rows to the database and import unless you can either resume it or you're running it in a transaction when the power fails, it rolls back. And it shouldn't matter if it runs 1 time or 1,000. And I say that and I realize as a programmer that's a lot harder than it sounds. Like that's actually probably one of the hardest things to do in Sidekiq. But doing all of that, you get a lot of advantages. You get this like fully flexible system that's fast and actually saves a lot of money when you have lots of things to do. So in the last few minutes, I just quickly want to run through some stuff very fast. So other tips to consider when you're doing it, tooling around Sidekiq, except for that's which built in middleware, is sparse. Metrics around performance specifically, or tools at runtime to inspect that. But we can, again, take advantage of another hack, tail the log files across 100 servers and view like how long things are taking. So we had a Capistrano task that would actually pull those out, pull the times, and have a continuously updating list of jobs. Jobs that took from 12 milliseconds to 172 seconds, which, yeah, that's not a good idea. But we did that just from tailing log files and like collating numbers. Really easy, really simple, lo-fi hacks. If you start doing more complex data imports and workflows and all that sort of stuff, you should probably look at something like Hadoop or other options. Things like if you're working out how to split and share files across different servers, don't just push them to S3, actually look at proper solutions. So in summary, and I'm going to speed through this quickly, understand how Sidekiq is designed and structured, because you can make advantage of those really simple hacks or the really complicated ones, because it's really well designed and it works together. Likewise, know Redis. Don't just know the commands Sidekiq uses. Actually have a look at redis.io and go through all the commands. There's a lot of really cool stuff and really, really evil stuff you can do with what's there, and Sidekiq uses that as its data backend. And know that you can do things in your Redis instance using Lua. So those cases where you have specific guarantees, you can push them into Lua. But don't limit yourself to what's there. Like you can replace different parts if you need to. You've just got to be cautious about not doing it in a bad, unmaintainable way. Queues are your friend. You should bend them to your will because they are very flexible and they're the like most lo-fi part of it all. And there's a huge amount of existing Sidekiq middleware, libraries for other languages and stuff like that that's just out there. People have already written it. Like things that add complex pipelines and all that sort of stuff, just Google it. And it's also important to consider when you should move to a proper message queue, because like proper message queues also handle a lot of this and better, but there's a bit of extra effort to do it. So to close off, I emailed Mike saying I was doing this talk, and the first question is like, there anything that I should tell people about Sidekiq? So there's 2 big updates to Sidekiq coming soon. The first is Sidekiq 3. Sidekiq 3's main feature is a dead job queue. So when a job fails, all of its retries, it'll automatically be pushed into another queue. Kind of cool. But for me, the big one, having done a lot of data import, so I spent probably about 3 to 6 months of my life doing data imports over the last 2 years, like hundreds of millions of rows, was this idea of nested job batches. So actually doing like this stage and this stage and this stage, where each stage is a batch, is really useful for those multi-stage data imports or complex workflows. And actually being able to do that in Sidekiq is a big boost. So that's kind of it for hacking Sidekiq. I hope you guys actually got some value out of that. I'm Darcy, and yeah, any questions?
Questions? Here's one.
Hey, thanks for the talk. Quick question about failure scenarios with Sidekiq. Like an EC2 instance might go down, but more likely the spot instance gets turned off. If the power's been pulled from it, then there's no ensure block or anything like that at the end of the middleware to handle what happens at the end of it. How does Sidekiq differentiate between something that's just vanished, or a long-running process where it has it timed out is an unanswered question?
So under the hood, Sidekiq doesn't, and that's the core part. Reliable queuing semantics aren't part of Sidekiq itself. The way you deal with that most of the time is you either implement, so in the case of unique jobs, you implement a lock and the lock has an expiry associated with it. So you make the assumption that it will check in. The other way you actually deal with it is in your application code. So for non-middleware stuff, use things like transactions and you basically design around the problem. And you design with, if you know what's going to turn off, the best you can do is kind of attempt to retry that job and recover from it. So it doesn't necessarily solve it, it just works around it by using, like, working with Redis smartly and encouraging the developer to be aware of it.
So the automatic retry doesn't kick in?
Yeah, so the automatic retry that I talked about as a feature is only for when, like, an exception is raised, essentially. So things like the good example there being you're working with an external API. As you can probably tell, I've spent the last 2 years as well working with APIs. The external API is down and I want to retry in like a few hours or that sort of thing. I don't want to instantly fail. That case there. So something outside of your control has failed usually. Sweet.
I'm not sure if you touched on it much, but would it help in the future for kind of Sidekiq projects to kind of have like a back end, like a web app analytics to kind of track schedules and see that kind of interaction, like a user interface style of?
So one of the early things I covered, I'll see if I can pull the slide up, was Sidekiq Web. So Sidekiq Web is basically a mountable Sinatra app that's included, that includes a lot of that. Things like metrics around, not necessarily runtimes, but how many jobs, how many are in queue, so like really basic stuff. And having that sort of stuff, so that tooling in a web interface is incredibly useful. And more importantly, like for us, we mounted it inside our Rails router, so just required Sidekiq Web, blah, blah, blah. But that said, all the performance metrics and that, and the stuff that you actually care about, it would be really useful having that in there. And it's actually pretty easy for someone to write an extension, again, store that data in Redis or even push it out to something like statsd and pull that into that interface. Like having access to that data, no matter how, is incredibly useful. And having access to us, the single biggest thing was number of jobs in the queue and that had been processed over the last few days, because you can see just looking at it visually at a glance, the power of that. Yeah, sorry, I hope that answered it. Cool.
Anyone else?
That's not to say we used Rabbit in a job a couple of years ago, and inability to introspect on the queue was one of the major. It was a massive cost.
Yeah,
Didn't provide that right tool.
that was the good thing for me, is having spent, like, honestly, I've spent hours on certain specific bugs, being able to connect to your Redis interface and look at the raw data that it's pushing there. And like, you have access to the code of Sidekiq and Redis. Debugging issues becomes a lot easier in that case. When you're dealing with, okay, why are we suddenly getting jobs that don't behave as expected? Or in our case, we had something where the retry limit was misconfigured to like 300 instead of like 3. Being able to look at that and see that a job was sitting on like the 257th retry was really, really useful. And probably the most powerful part of using Redis as a backend.
Cool, let's thank Darcy.
Thank you guys.